Have you ever faced a knowledge base that knows it holds information that you need, but you didn't know how to extract this information? And let's be more specific because it's the Knowledge Graph conference. Have you ever faced a knowledge graph that you know that contain information that will increase your data and increase your result and evaluation results, but you didn't know how to extract the exact data that you need? My team and I also has this problem. And today I'm going to share with you how we provide an hybrid AI approach to solve this problem. So I'm Hodaya Binyamini from Accenture Lab, the cybersecurity lab in Israel. My team provides AI solutions for cybersecurity problems. And in my role, I'm providing an AI solutions as an applied research. In this talk, I will start with introducing the problem. I will tell you about our specific use case, which you may guess that it's a cybersecurity use case. Then we will go and talk about our solution, our evaluation, and at the end, I will summarize that. So let's start. As I said before, you have a knowledge graph, and you can have the access for all the data in the knowledge graph. And you have a new object. In our use case, it's a textual description, and I will talk about it more. And you want to correlate between this textual description to the knowledge graph, but you don't want all the knowledge graph. You want a specific part. You may think like, oh, maybe I can take an ID or a name or a specific value. But this situation is different. Here you have a textual description. You don't have any ID or any name, and you want to correlate it and extract the information that you need. And let's talk about our specific use case, our cybersecurity use case. We have in our graph the weaknesses nodes, and we have nodes that describe the attack pattern. And we have nodes that describe the attack techniques. And we have nodes that describe the mitigation. And we want, given a cybersecurity finding textual description, to extract information just like what is the technique and what is the mitigation in order to mitigate our security finding. We want to find how to extract all this information. To solve this problem, we came with two research questions. We separate it into two phases. The first one is how to correlate between a specific entity from the graph to our finding. We can look at it as a gate for our graph. And the next one is how to retrieve the right recommendations from the graph. You may think how we build our knowledge graph. So our graph contains information from NIST and from ITRE. NIST contains information about vulnerability description. It's publicly available, and the information there is textual descriptions of common vulnerabilities. Each vulnerability calls CVE, Common Vulnerability Exposure. And some of the vulnerabilities are related to weaknesses, which we can extract the weaknesses from ITRE. ITRE also contains the attack patterns, the attack techniques, and the mitigations. Each one of those classes contain textual description and may contain relation to other classes. In our situation, we took the vulnerability descriptions and we want to correlate between them and to the weaknesses. Here you can find our graph schema. And if we will look at our specifically part of the schema that we want to use, we want to take the CVE and then correlate it to the CWE. afterwards to the pattern, and afterwards to the technique. And each one of these nodes may contain a specific mitigation. Um, we separate our use case in this manner. We took the vulnerability textual description, and then we want to extract what are the attack techniques, are the threats, and then we want to extract the mitigation from the graph. And we will start with the first phase about how we correlate the text to a CWE. Also here we have two parts. The first part is classification, and the second part is out of distribution detection, and we will talk about both of those parts. Our data look like that. This is an example from NVD. This is an actual textual description, and this is how it looks like. And this vulnerability description has the related CWE, which is the class here. If you look at our distribution, you may see that our class distribution is very imbalanced. In order to imbalance our data, we undersample the classes with the most number of samples, and we oversample the classes that have only few samples. This is how we created a balanced data set. And who is BERT? I think that most of you pay attention for this model. BERT is bidirectional encoder representative transformer, which is an attention-based model. BERT is a pre-trained model that was trained to give an embedding for text. And it has out-of-the-box pre-trained models that came to solve specific NLP problems, just like name entity recognition, part of speech, and sentiment analysis. Sentiment analysis, it's like like sentence classification. And to solve our problem, we fine-tune this specific model with our data. So we took the BERT model with the two outputs, and then we fine-tune it over our data that contains more than 164 weakness type, which is our classes. In our data set, training data set, we have more than 32,000 vulnerability descriptions that we took from NVD and Intelgraph, which Intelgraph is an Accenture internal tool for cybersecurity. And as you may know, not all the text descriptions are related to cybersecurity and are not even vulnerability descriptions. In order to handle this problem and make our model to be right, we want to filter out all the descriptions that are not relevant. We don't want that our model will classify wrong these text descriptions that are not related and are out of our context. In order to do that, we may think about few ways. One way, we thought maybe we make a classifier, but it will be very hard because we can't get all the data in the world. So we decide to check what is the uncertainty of our model. We think that if we will understand if the model is sure about the classification, so the data is related to our context. This is why we use an entropy, and our method based on entropy. And we look at it in two phases. In the training phase, we took all the samples from the training data, and we take for each sample the last layer probabilities. For each one of these probabilities vector, we calculate the entropy, and then by have all the entropy values, we define what is the threshold that tell us if the data is related or not related. In the query phase, we take the last layer, we calculate the entropy as human think, and then check if the value is in the entropy range. If the value is out of the range, so we don't return what is the CWE ID or what is the class, we say that it's not related to our problem. So maybe you should check it. Let's talk about the evaluation and numbers. We have done 2 evaluations. The first evaluation may be a more classical machine learning evaluation. We separate our data to train and test, and then calculate the results. As you can see, our F1 score for the train test phase is around 84%, which is very good when you think that we have more than 160 classes. And the second evaluation is a bit different. We took the finding description from red team in Accenture. Remember, this is an internal data, so no one tells the red team people how to write the description, and no one tells them the structure, or no one make a review over this data. Instead of the data in NVD that it's publicly available and there is a review, here you have really free text that no one validated even. And look how valid our result. We have around 60% of F1 score. And remember, always remember that we have a lot of classes. It's much better than only guessing. I can share with you that our result about the next recommendation, which are not the first in the first part, are also better. But I want to be I want to keep it. If we take here only the first prediction, here I also give the result only for the first prediction. Now we can go to the second part of this of our approach. The second part is retrieve the relevant information from the graph. So we took our finding description, and we have now the right weaknesses, and which is a node in the graph, and we can have a gate to the graph. When we have this weakness, this class, we can find what are the patterns. The patterns are correlating to the weakness. Also, we can find what are the technique, what is the attack techniques. And then we can find also what is the mitigation. All this data we can find from the graph retrieval. Let's look at this example. In this example, we can see that there is a CVE, the textual description. We correlate it to a CWE, which is the graph, which is the class, and also it's a node in the graph. And then we correlate it by the CWE to all those information from the graph. What is the attack pattern, which is the CAPEC? What is the attack technique? What is the attacker threat? And then what is the mitigation? That by know what is the mitigation, we can understand how to mitigate this specific vulnerability and avoid that. So let's talk about the keynotes and what we saw in this talk. The talk is in generally about how to automatically retrieve information from the knowledge graph. And we have an hybrid AI approach contain 3 main parts. The first part is LLM-based approach to correlate between the textual description to a specific class. The second part is OOD detection, out of distribution detection. Remember, not all the text is related to this use case, and we want to filter it all out. And the third part is using the knowledge graph and the graph traversal to retrieve the specific information. So before I end this talk, I want to give you two options. And one, scan this QR code if you want to see more of our projects in Accenture lab. And the second one, scan this QR code if you want to connect and we can more talk about this information and this area field of study, NLP, knowledge graph, machine learning, and cybersecurity. Thank you, everyone. I really enjoyed this talk. I hope you enjoy it too. Now it's your time for Q&A. Don't be shy. Yeah.
Quick question. So I think two parts. So the first part is like the when you try to connect the CVE to your knowledge graph here. So the purpose looks that you try to give the developer's recommendation, right?
Mm-hmm.
CVE is about this vulnerability. So have you ever considered how like you suggest developer to enforce those mitigation?
What do you mean enforce the mitigation?
Like you put, you got a CVE.
Yeah.
You read the description, then you expect developers to do something, right? To mitigate this vulnerability. So in that case, so you just give like a document, like this is a CVE, developer need to read. Then whatever they are going to do, they need to follow instructions. That's it, or you give more than the developer to do, like give them like hey, this is where you need to fix on your system leaks for this vulnerability. So what kind of granularity do you finally provide the developers?
I try to understand it more specifically. You ask why do we need the...
Not why, what kind of granularity? So which means like, yes, this is CVE description, the document, right? The developer will read that document. It's really long. Maybe need time to digest that, right? Do you give like the more fine granular information, like for developer know what exactly they need to enforce, what exactly they need to do to resolve some like the vulnerability? Have you thought about that?
In this specific use case, we have the descriptions. Like this is the granularity that we look at. We don't have more information or a different type of data to handle. We took the CVEs because this is how very close to finding descriptions that red team guys can bring us, and it was close enough. And also, if you look at NVD, you can see that there are not some, but there is a percent of CVEs that have a correlated CWE. So if there is a correlated CWE, it makes it easier for us to find it in the graph. Yeah. Thank you. Yeah.
I would like to ask a question about since you mentioned the red teaming, cybersecurity incidents taking place that you need to act so quickly. Where do you think your approach is fitting in that lifespan of, let's say, cybersecurity attack is taking place right now? Red team has to decide what to do next. What is the expectation from your side where your recommendation system fits into red teaming approach?
So if a red team member writes finding a new finding description, right, he finds something, right, and he gives it to inside the tool and write, I found a vulnerability that in software which is or without like a software name, and it give it inside to the tool in this tool, okay, and it get back the mitigation that he made, mitigation recommendation that are supposed to be good enough in order to mitigate this problem.
So then your approach is not an active measurement and active response, rather passive when someone is, it is more of blue teaming in my opinion, that someone is passively looking into logs and figures out that there's an incident or there's a particular vulnerability I figured out, what we can do about this. But it would not be red teaming.
The tool may help to blue team, but the information that I get was from the red team. This is why I said red team.
Okay.
Okay.
All right.
Okay. Yeah.
Okay. Just a quick question on, you mentioned that you were setting a threshold on the entropy to figure out the deviation.
Yeah.
How did you kind of figure out that range or what your threshold is?
What do you mean? What's the number?
Yeah, how did you decide what was too much entropy?
If it's too, okay, I got it. This is why, as I said before, I took we train the BERT model, right? So we have the training data. And by using this training data entropy values, we calculate the entropy value for each sample in the database, in the data set, our data set. Okay? So we know that all the samples of our data set are related to any specific class. So this is how we define the entropy threshold. We know that if something is above, so it doesn't relate.
Okay, got it.
Okay, great. Yeah.
Yeah, sorry, I came in late. You may already mention in your presentation. It's like your knowledge graph. How did you build that knowledge graph up front? Do you have that already when you have this project, or you built that from somewhere?
So we take, it's written over here, we take some data from, based on the VON, okay, which is an open source data collector. And we took the data from NIST and MITRE. NIST contains a vulnerability textual description, and some of them are correlated to CWE, which is a part of MITRE. MITRE has information about weaknesses, patterns, techniques, and mitigations. And it may have correlation between them. This is how we create the database.
Okay, thank you so much.
Anything else? Okay. So thank you, everyone.
Let's go. We'll take a break. Yeah. Yeah, I was telling you about saw the orange juice. That's good. It reminded me that taking the zinc in the coffee. That has helped me to keep up with my immune system.